It organizes analytical state in a graph structure which can be revisited and shared with colleagues.
The recent COVID epidemic has triggered several different crises that are testing our civilization's potential for both coordination and cooperation. Data about infection rates and their growth has been the main source for public discussion and has inspired many visualization works. We propose a VA approach that incorporates a growth predictive model. This allows the correlation monitoring of the virus population development. We also can relate it to different government response events, as well as identify key dates.
Smartwatches can track a wide variety of data. We are interested to learn which type of data people consume and how it is visualized. To find out, we conducted a survey with 237 participants. We found a predominant display of health fitness data, with data mostly displayed as icons with text. Based on our findings, we discuss opportunities for visualization research on smartwatches.
Evaluating alternative interpretations is an essential part of complex sense-making, but the resulting ambiguity is rarely considered in the design of visual analytics systems. Avalanche forecasters rely on sparse and human-produced data to assess avalanche hazards, often resulting in ambiguous interpretations. We used simple glyphs and unit visualizations to specifically consider and support ambiguity in the avalanche forecaster's sense-making processes.
Nowadays, online services are used for all kinds of activities. Strategies to increase the situational awareness of personal data stored by online services are needed. We present Transparency VIS, a visual, interactive web application. It allows common internet users to explore their personal data exports, which can be requested from online services like Facebook, Google, Instagram, or Twitter. Feel free to try it out online.
Imagine you have tons of text data to analyze. And you want to get an overview of your data, but traditional topic modeling techniques such as LDA are not working for you. Then, why don't you try Architext? We introduced a scalable and flexible way to interactively build hierarchical topics.
When visualizing data in a realistic rendered 3D environment, it is important to represent the data in a readable way. In our work, we investigate how the opacity affects the readability of a 2D shape and determine useful opacity ranges. Therefore, we performed a user study with different overlay configuration like filled, striped, and dotted pattern, the density, and considered the effect of an outline.
Greetings from Salt Lake City. I'm Chris Johnson of the Ski Institute at the University of Utah and chair of the VIS 2020 Memorial Session. This year, we lost 3 pioneers: Alfred Inselberg, the innovator of parallel coordinates; Bill Lorensen, the creator of marching cubes and contributor to the visualization toolkit and ITK; and Lucy Nowell, known for her work in information visualization, the Theme River system, and also for her federal leadership. Since we are not able to share our memories in person and raise a glass to toast Alfred, Bill, and Lucy, we have created 3 short videos to share with you today. A big thanks to Wes Bethel, Ben Schneiderman, Bob Laramie, and Nathan Galley for helping to put together the videos, and for all of the people who contributed to the videos that you're about to see. Let's now share these video tributes to Alfred, Bill, and Lucy.
Alfred Inselberg's breakthrough idea of parallel coordinates changed mathematics, science, and engineering forever. His startling idea was to go beyond the 16th century notions of René Descartes, whose Cartesian coordinates enable us to represent 2-dimensional and 3-dimensional data conveniently. But Al Inselberg's idea took us to 4, 5, 6, and more dimensions. And that's been profound change. I first heard Al speak in 1979 when he visited the University of Maryland. His talk just was a mind-expanding experience. I could see the potentials and the importance of what he had done. And his talk was charming, filled with great examples that showed the importance of what he did. And his charming little touches, such as if someone asked a question, they would be rewarded with a toothpick or a paper clip. And those little ideas just made him a charming figure. I was proud to write the preface for Al's 2009 book on parallel coordinates, which helped document all the ways in which engineering, science, and mathematics could use these tools. Sadly, Al died in 2019, December, of cancer, but he'll always be remembered. The dozen times I visited with him in Israel and in the US and at conferences were memorable, and they helped clarify for me the ideas that I was missing. He was such an important figure in shaping my ideas, and my respect continues. But it's also a great pleasure to remember Al for his bubbling smile that filled the room, his enthusiasm that made you want to be close to him. And it's that experience and pictures like this that make me remember the happy face and the important ideas that Al Inselberg brought. This video tribute was requested by Chris Johnson for the IEEE Visualization Conference of October 2020, and I was pleased to have Robert Laramie join me in putting this together and inviting other people to make a tribute to Al Inselberg. Thank you for this opportunity.
Thanks for inviting me to share the beautiful memories of my interaction with Professor Alfred Inselberg, first as a professor, then as a thesis advisor, a mentor, and a great friend. We met in early 1990s when I was a PhD student at UCLA. Under his guidance, I started my PhD research on robotic navigation while he was at IBM Research Center in Santa Monica, where these pictures were taken. We applied the basic ideas of parallel coordinates to robotic kinematics and trajectory planning. Alfredo was always there to encourage and provide advice and humorous relief when I needed, either in front of a cappuccino in the Santa Monica office or a Chinese dinner in Westwood. When I moved back to Italy, I had the opportunity to invite him and his family to Verona. He visited me one last time in May 2018. The weather at the time was great, and we did long strolls through the city, and I enjoyed listening to his seamlessly endless stories. In the 30 years that we have known each other, it was always great to spend time together, and his memory will be always very dear to me. Thanks, Alfredo.
About 5 years ago, I accidentally discovered him again when I found his book just randomly in the library, and really found it extremely useful and incisive and edge-cutting, and it was really something that I could use because I needed something that I needed to plot a bunch of functions with 30 variables. So I wrote to him, and we became colleagues again, and actually published a number of papers and have 2 in the mill. So I am really, really honored to participate in this celebration of his life, and thank you for asking me.
Hi, I'm Robert Cosara. I'm a research scientist at Tableau. I remember reading Alfred Inselberg's papers back in the 90s as a wee grad student and being fascinated by them and the ideas in them. Interestingly, Alfred wasn't really a visualization guy. His passion was high-dimensional geometry, but I think he embraced visualization more as visualization paid more attention to him and his work. He started appearing at conferences, though I think mostly not academic ones, and also emailing people who were working on parallel coordinates papers to encourage them and to promote his technique. And parallel coordinates have certainly been a big part of the visualization literature of the last 20-25 years or so. I've done some work on them myself, with my former student Aritra Dasgupta and later Min Chen on how to assess the properties of parallel coordinate plots and how to use them in a privacy-preserving way. And back in 2006, I wrote a paper with Helvig Hauser and Fabian Bendix on a technique called parallel sets that used the basic idea of the parallel axes but for categorical data. I actually met Alfred once back in 2013 when he gave a talk at Tableau. It was an interesting experience because he was actually quite the character. His talk was really more him telling stories and jokes about how he had come up with parallel coordinates and how he'd used them in a number of different projects that he had done over the years and so on. He was also quite irreverent and funny, like the slightly weird but actually funny uncle that you never had. I think Alfred's work and his way of thinking have left a clear mark on the field of visualization, and his legacy will live on in a lot more work, either directly using parallel coordinates or certainly being inspired by them.
The first communication that I had with Alfred was back in 2008, and then we finally managed to meet each other in 2010 in Beijing. And the year after, in 2011, Alfredo visited me in Cambridge, where he spent a few days. We then had our first tutorial in 2014 in Paris, where we did sightseeing. That was one of Alfredo's best when we met in various places, but we also made good friends. Then in 2015 in Hobart, we gave another tutorial, and again we had long discussions about everything. Alfredo was a good friend, a good educator who had a special relationship. In 2016 in Lisbon, where he met also my wife, we gave another tutorial, and again we made good friends. We did sightseeing and enjoying every moment. In 2019, we visited my old university, University of Patras, where we gave a lecture, and then we continued our trip in Kalamata, where we gave a tutorial, again making new friends, but we also did sightseeing. where we visited the Temple of Apollo. Alfredo enjoyed our time there very much, but we also, as he always liked to cross boundaries, we entered into the temple. He really liked Blita and he missed them, but of course Alfredo will be missed from all of us. And I would like to add to his saying, do it in parallel, I would say also to do it with friends. It is always more fun.
Back in 2011, Zhao Gong, one of my all-time favorite PhD candidates, and I published our first paper on parallel coordinates. Shortly afterwards, Al sent us an email. Hi Robert et al. I was delighted to see your nice paper. Congratulations. By the way, I may be in the UK in Cambridge at the end of August, and it would be happy to meet if it's convenient. Best regards, Alfred. I was so happy when I got this email. I was jumping up and down, and I printed it out and hung it up on my wall. Here's the printed copy. Al was one of my scientific heroes. Gong and I then went to Cambridge University to meet both Al and Timos. It was one of the most memorable trips of my entire life. I was shocked at how funny and charismatic Al was in person, having seen mostly the scientific side of him up to that point. I loved listening to his talk, stories, and sense of humor. From that occasion onwards, Al and I kept in regular contact all the way up until 2019, and we met each other at a number of conferences. I was always happy to see Al in person. Although Al's physical form may have passed, his spiritual and scientific presence will live on as long as we are trying to understand multidimensional behavior. Thank you so much for your contributions, Al.
Al Inselberg was a giant, and not only literally. His parallel coordinates are a very ingenious and effective method for dealing with the most ubiquitous type of data we have, high-dimensional multivariate data. Parallel coordinates are used by many people for many different purposes, leading to many new findings and insights. As an example, my students and I have used parallel coordinates many times. Look at our last Pacific VIS paper, and you'll see parallel coordinate plots. This method is a true cornerstone of visualization. Al was a tireless ambassador of parallel coordinates. Many of us will remember his talks, tutorials and keynotes, lively, entertaining, and also providing deep insights. Especially that there are deep layers in the method which are not obvious at first sight. Unfortunately, Al is no longer with us, but his work will live on forever.
Hi, I'm Yuval, one of Al's children. First of all, I want to say thank you to everybody who has participated in this tribute. It's very touching, and we thank you all. So first of all, I want to start and say that I always remembered my father coming back from this conference, very enthusiastic, telling us stories about the wonderful people he met and the very inspiring ideas he discussed in the conference. And also I want to say that my father ingrained in us, and also in me, the value of education, data, and numbers. And also because of that, I have chosen a career path of being a data scientist. And I am practicing in my work the principles of data analysis, visualization, that my father taught me throughout these years. And so here you can see my work set up, my homework set up for COVID-19. And just wanted to share two photos that I have above the screen. Here you can see my father with Mike and Bernie here and here at an IBM Scientific Center. And occasionally I look at these photos and it gives me a lot of inspiration because I think to myself, these are the early days of computer science, of data analysis and all this stuff. And then, you know, I remember like where a data scientist is today, and it's very inspiring to me. So yeah, I just wanted to share that. And to finish, I'm hoping that my father's work will continue to impact this field in a positive way. And thanks a lot.
Hi everyone, my name is Akiva, Al's youngest son. I'm here in Tel Aviv in the magnificent Abima School. First of all, I want to thank you all for letting us show our respect for our late father. He enjoyed participating in the conference year after year and meeting interesting people. His expertise didn't end with multidimensional graphs and mathematics. He had a huge curiosity for all sorts of topics, including Jewish history, law and economics, philosophy, and even art. Every question I used to ask him, he always knew the answer to. And most importantly, he knew how to explain it. I was astonished by it every time. I used to flatter him and call him a polymath. Honestly, it was not just a flatter. I truly meant it. I want to thank you all again for this wonderful tribute. Myself and the whole entire Inselberg family appreciates it immensely. Let us all hope for better times for humanity. Thank you and goodbye.
We love you, Grandpa. You will always be in our arms.
Thank you very much for giving me the honor of speaking about my dear husband. We have lived together for 47 years. Our life was wonderful. We raised 5 beautiful children, and we had a lot of time together, spending, joking, telling stories, and doing things together.
Hi, I'm Donna. I'm the oldest of Al's 5 children. I wanted to thank Bob and Ben and everyone who participated in this beautiful tribute for my father. It's extremely touching for us because my dad loved this conference. He attended it religiously and spoke many times. And he enjoyed traveling to conferences all over the world and meeting amazing people. Thank you so much.
Bill Lorensen died on December 12, 2019. Given the outpouring of grief from his coworkers, friends, and family, it is clear that he will be greatly missed. When we think of great influencers in fields like computer science, we tend to focus on technical excellence. Bill had this in spades. He was involved in the creation of core software systems, algorithms, and workflows. Along with Harvey Klein, he created the most widely cited visualization algorithm, marching cubes, which has been used in a huge number of applications. As of September 18, 2020, Google Scholar reports over 16,000 citations of the Marching Cubes paper. His 1992 paper on triangle decimation with Will Schroeder also ranks among the top 10 cited SIGGRAPH papers of all time. He was a co-author of the seminal book, Object-Oriented Modeling and Design. He had over 31 US patents. In 1991, he was recognized as a GE Coolidge Fellow, the company's highest author. And in 2004, Bill received the IEEE Visualization Career Award. He was a principal architect of the Visualization Toolkit, VTK, and the Insight Toolkit, ITK, and also 3D Slicer, all open source projects with vital communities that continue to change the world. He was a SIGGRAPH and visualization pioneer. Bill was a fixture at ACM SIGGRAPH and at IEEE VIS for decades, eventually serving on the as awards chairman for the VIS conferences. The continuing impact of his ideas have been profound, and his personal commitment helped to shape the dialogue for graphics and visualization research for over 40 years. Anyone who had the happy opportunity to work with Bill can tell you that he had an understated influence, which continues to provide lessons to all of us. In this short tribute, we will provide short personal stories from a few of Bill's friends and colleagues.
How do you describe Bill Lorensen, a talented and creative mathematician and computer scientist? a great communicator, able to build strong collaborations within his own work environment and also externally within the scientific community. Bill's ability of collaboration was simply exceptional. A natural technical leader who again could build networks both within and outside his community to achieve outstanding research results. Within GE, Bill was one of the first people to advance the use of the internet and object-oriented programming. He was recognized by his research peers within GE's Global Research Center with the William Coolidge Fellowship Award, the highest award of research recognition within GE. Bill was the technology leader and glue of our visualization group. Bill left us far too early. We will always remember Bill for his great wit, his affable nature, and his deep friendship will always be a part of me.
My name is Vince Cavullo. Bill joined my group at GE Research in the late 1970s. We worked together on many projects. His technical achievements and accomplishments are well documented. Bill and I were very close friends for over 40 years. We did many things together. We fished, we played golf, we played the horses, and on and on. Everything we did was lighthearted and fun. Above all, Bill was a dedicated family man. He cared greatly for his wife, daughter, and son. There wasn't anything he wouldn't do for them. As a friend, Bill was just as positive and upbeat as he was at work. He never had a bad word to say about anyone. He never uttered a foul word. Instead, he looked forward. He looked for solutions. He looked to the future. He handled his last months with dignity and class. He never complained. We have lost a great person, but we have not lost what we have learned from him. Bill, I was lucky to have you as a friend.
What I remember about Bill Lorensen is the twinkle in the eye that told you how much he loved what he did, and the twinkle in the eye that told you how much fun you would have when you worked alongside of him.
Thanks for the opportunity to join you today. Bill Lorensen was a remarkable individual. He was incredibly gifted, and he shared those gifts with many colleagues in the broad community of software innovators and developers. He was always positive, but also pragmatic, developing algorithms, building translational platforms, and adopting new approaches to teamwork. Following his leadership, many people, including many of us, were able to work far more effectively and efficiently in engineering design, commercial visualization, medical imaging, and other fields. He convinced many of us of the virtues and advantages, particularly the quality of open source software. He was an exceptional collaborator, and at every scale, he helped gently guide people around him to create and to grow. We have been lucky to have Bill as a mentor and as a friend. We will remember his upbeat and constructive attitude and the resulting accomplishments as examples for us all. Thank you.
Hi, my name is Ron Kikinis, and I am delighted and saddened at the same time to give this tribute to my dear friend, Bill Lorensen. I met Bill Lorensen in 1988 when we started collaborating on augmented reality applications in surgery. Since then, we had been working together on a variety of different interesting projects. And during that time, we became friends. And he was also, to me, a teacher and mentor. In particular, I learned a lot from him about open source and the philosophy of open source and working in a community. His personality was well suited for community style work. He was always friendly. He had always a smile. He liked to tease, but in a nice way. Nobody that I know of was ever upset at him. He was so nice, but he was also extremely competent and extremely knowledgeable in his field. And it was a pure pleasure to working with him over the decade.
The singer and songwriter Billy Joel once answered his daughter's question, "Where do we go when we die, Daddy?" with the following reply: "I believe that you go into other people's hearts. When you pass into other people's hearts, and you are taken into their lives for the rest of their lives. And they pass that on, just like music, it never ends. It goes on and on." Bill Lorensen touched so many lives when he was with us. He was a teacher, a mentor, an advisor, a leader, a thinker, a socializer, a scholar, a great man, and a warm and caring friend. Of all those people, I miss the friend the most, the lover of beer, the player of golf, the curious and playful mind. By touching so many lives, so many hearts in his time with us, his footprint on this world is vast. He has gone into our hearts, into my heart, and I will carry him for the rest of my life. I see his reflection in my students, my colleagues, and my friends. I miss you, Bill. I celebrate you, and I will never forget you, and thus you will always be with me.
I first met Bill in 1992 at my first visualization conference. And I believe it was my advisor, Ari Kaufmann, who introduced us and said, "This is the guy who invented marching cubes." And I said, "That's great," but I didn't really know what that was. So then later I found that marching cubes is, of course, one of the most cited and probably one of the most influential algorithms in all of computer graphics. And Bill, typical to his nature, very humble, didn't even make a big deal about that, and just was always so welcoming and open to talk to especially junior people about visualization. So my memories of Bill over the years are really of him being a super geek, interested in all kinds of algorithms, interested in software engineering, but also really fun to argue with on panels about the benefits of marching cubes versus raycasting in volume rendering. And always very happy to have a beer with you and sit down for a chat. So Bill, we all miss you very much. He was a statesman for our field. He was a role model for all of us, and we always will miss him.
So Bill always made everything more fun. And even after he retired, he used to hang out and be on advisory boards, stuff like that. So one time we were having a meeting online, and every few minutes, the screen would go like this. Right? And then we go on, Bill would keep talking. And then at one point, after a couple times like this, I said, "Hey, Bill, why do you keep showing us a picture of your stomach every 5 minutes?" And he said, "Well, I thought it might be recorded, and I didn't want to see him drinking my beer at 2 o'clock in the afternoon."
I met Bill just as I was entering grad school. At the time, he would come over to RPI for an afternoon every couple of weeks to talk research. After grad school, I joined Bill over at GE and worked with him until he retired. We could fill this week recounting Bill's stories. We can celebrate Bill's contributions to the field. Bill was there at many of the beginnings. But the things I remember most about Bill have to do with how he did things. First, he had a way of connecting, which led each of us to feel like we were his best friend. Second, he showed us a technical career path that avoided going into management. And third, he was our biggest fan. He was always promoting the work he had seen and connecting people to opportunities.
My friends and family knew Bill Lorensen as the 800-pound gorilla because that's what I referred to him as whenever he wasn't around. However, I meant that phrase only out of deep respect. Bill had such a commanding presence whenever he entered a room. And yet at the same time, he was more kind, considerate, and helpful to me than what I ever deserved. But that was Bill's default with people. He always assumed the best in them, and he brought out the best in them. And that's what made him such a great leader, as well as so well respected by his peers. I'm forever thankful for having had the opportunity to get to know Bill, to work with him, and to learn from the examples that he set. Thank you, Bill.
Cheers, Bill.
Cheers, Bill.
Cheers, Bill.
Cheers, Bill.
Cheers to you.
Cheers, Bill.
Cheers.
Cheers, Bill.
Cheers, Bill.
Cheers, Bill.
Cheers, Bill.
Today, we're here to celebrate the memory of a dear friend and colleague, Dr. Lucy Nowell. Lucy was a giant, a titan, whose efforts had a broad and deep impact on the field of scientific visualization and on the careers of dozens, perhaps hundreds of people in our field. Her educational background was eclectic and includes graduate degrees in theater and drama. Her first love was theater, which resonated with her deep passion for life and its expression. She was a tenured professor of dramatic arts and led the theater program at Lynchburg College. Then she shifted gears and earned her doctorate in computer science from Virginia Tech. After a few years in academia, she began applying her unique skills and user experience in the emerging field that became known as visual analytics. On 9/11, she had a profound epiphany that would shape the trajectory of her professional life. As she told it to me, she was physically at the Pentagon when the attack came. In the days that followed, while marooned on a friend's couch in the DC area, this epiphany became her life mission statement: to bring people together to work on problems of national importance. Today, you will hear from several persons who each have unique insights as to how Lucy has served as a mentor, champion, reality checker, trailblazer, and much more.
In remembering Lucy, I often think back to our many long and rambling and very productive conversations in her office in Germantown. She had a round desk piled high with papers and books, usually some excruciatingly personalized Excel budget document on the computer, and many photos of her loved ones on the walls, both the human and the canine kind. And she often wore a pop of color, a statement piece of jewelry. I think I'm drawn to this visual memory because it says so much about how Lucy presented herself as a whole person. She was all of these things, detailed and big picture, professional and personal, flamboyant and measured. And I think she saw other people this way too, as a whole person. Lucy made many important contributions to the Oscar mission in the time that I knew her, including her leadership of the field of scientific visualization, her contributions to the research foundations of the Exascale Computing Project, as well as scientific computing post-exascale, and putting experimental and observational data on the map as an important part of our mission. Perhaps most telling, though, and I think the things she would be most proud of, are the many research achievements and careers that flourished under her watch. On behalf of Oscar, I'm honored to have this opportunity to remember and appreciate our colleague and friend, Lucy Nowell.
I first met Lucy several years ago at Pacific Northwest National Lab. After I gave a presentation, Lucy introduced herself and told me about her research and user interfaces and the importance of getting feedback from users to better guide interface design. I had no idea then how much Lucy would influence the field of visualization and my own career. I got to know Lucy over the years and discovered that her first career was in theater and that she had been a professor of theater for several years until deciding one day to become a computer scientist and obtained a PhD in computer science from Virginia Tech. Lucy was an enthusiast. She was passionate about everything she did, from her commitment to changing the world as an NSF and DOE program manager to her love of theater and for her golden retrievers.
What I want to say is that I feel I owed my entire career to Lucy. Lucy has a precise vision about how visualization should and help computational sciences. She cares a lot about people around her, and she always held us to a very high standard for the quality of the research that we do. Because of Lucy, I was able to establish a group to nurture many young talents in the past decades. Lucy's support allowed me to develop techniques on information theory, distribution-based modeling, and ensemble simulation data analysis for scientific visualization. Dear Lucy, I myself and all my students and the past graduates from the Ohio State University, thank you sincerely.
I first met Lucy when she visited Berkeley Lab when I was a young scientist. From that first meeting, it was very obvious that Lucy was passionate about supporting young researchers and making a change in the world through science. Subsequently, I was funded under a program that Lucy managed. Lucy, with her background in human-computer interaction, recognized that scientists were an important element of science and that we often didn't address usability when considering interfaces for HPC software stack. She recognized that we needed a concerted effort to develop an understanding of human practices and scientific pipelines and drive usability at every level. Lucy really cared about the people around her. She always saw herself as an enabler and connected people and made sure researchers had the resources to do quality work. She went above and beyond to take care of the little and big details, whether it was the dietary restrictions at a meeting, thinking through the agenda, or making sure we had diverse teams. I will always be thankful that I had a chance to know Lucy.
Lucy was an amazing person with many talents. She played many roles for me and members of our community. She cajoled us and she praised us. She listened to us and she spoke to us. When she spoke, I listened. She knew a lot that I didn't know about how to engage our funding agency. And I don't think I was the only person to learn from her. I think many of my Department of Energy colleagues did as well. For me personally, I can say with no reservation that I would not be where I am today without Lucy. She also offered a lot of really good coaching on how I could modify my research, not just so it would be more impactful for the scientific visualization community, but also to my stakeholders and to my funding agency. And Lucy was just an incredible mentor who invested in me greatly. She was also an incredible person with diverse talent. She had a deft feel for when to speak, when to listen, when to praise, when to criticize. And finally, she just cared so much for the people around her. So I am going to miss her greatly.
Over time, I realized that Lucy was one of the smartest, most educated people I knew. Lucy was interested in and knowledgeable about everything. In her own words, she was an artist and a scientist. Lucy was the best speaker I have ever heard. Due to her first career, which was in theater, she could talk to an audience of 2,000 or 2,000. She had a mastery of everything high-performance computing and could easily articulate complex concepts in easy-to-understand terms. Personally, one of Lucy's biggest passions was her beloved golden retrievers, Sunny and Molly. Some of our best discussions were about what the dogs had gotten into lately. Frank was the love of her life, the man who brought her roses. Lucy, I will miss our dinners and discussions.
Lucy used to say that art is the force that slips in behind you as you're closing the door, a steady background, guiding presence that settles in the corners of your consciousness and shapes your world. She saw long before the rest of us the potential for artistic expertise via visualization to impact our understanding of data and thus science. I assume that conviction stemmed from the same source that provoked and enabled her to move from a stable 20-year career in the theater to becoming a guiding force in computer science visualization. She certainly was a force of nature. But for me, she was also a steady, encouraging presence as I waded into a culture where the language was foreign and the practices unknown. Mostly, I'm grateful for the dinners, where we found common ground, laughing over our large, unused collections of fabrics and the other absurdities of our lives. She was a mentor, a shepherd, and a joy. I'm left with the mystery of how someone who I saw infrequently has taken up permanent residence in my memories and in my life.
Lucy was special. When I first met her on a visit to PNNL, and I found she had DC links, we figured out how to meet. When she came to NSF, we shared the delight in all things data and set out to make a difference, changing the sharing of research products forever. Perhaps the most memorable of the NSF days was the first DataNet site visit, fondly remembered by a sacred view. When she moved to DOE, Oscar had no idea what was coming. She led and she mentored and then she retired. Brilliant move. I loved her intellectual honesty, her commitment to science, her fondness for a good glass of wine and a great cup of coffee. But data, visualization, and the next generation of computers, programming, and computer scientists will all feel her presence.
She was special. Finding one word to describe her, it doesn't work, at least not for me. In no particular order: professionalism, intellectual integrity, passion, dedication, and commitment, focus on standards of quality, both for herself and for those who were fortunate enough to be in her sphere. All of these superlatives, in any order, are more than justified, and yet they fall short of truly capturing Lucy, at least as I remember her. Lucy was one of those few who was a good person, who didn't just act or behave good, but truly was to her core a good person. And those of us around her, we felt that goodness. Maybe the best I can say, even as I see her smile in my face, hear her voice in my mind, is that Lucy is someone who we will miss.
Lucy Nowell had a passion for bringing people together to solve important problems in science. As a program manager, she set a high bar for those she worked with. She expected strong technical contributions, and she cared deeply about the people and their partnerships. She demanded integrity, and when conflict and adversity arose, she dealt with it in a direct and an inclusive manner. Her leadership philosophy and day-to-day actions left lasting impacts at the community level, and for many of us at the individual level as well. Personally, Lucy taught me one of the most important lessons in my career. She taught me the importance of authenticity in leadership. Lucy marched to the beat of her own drum. She was respected by the community for her technical vision and her integrity, while always remaining true to herself and being very uniquely Lucy. She was an inspirational role model for many of us, and although Lucy will be deeply missed, her impacts will continue to be felt for years to come.
Lucy was my hero, my mentor, and my friend. Her vision for effective scientific data understanding and visualization inspired a generation of visualization researchers. Her commitment to service is an inspiration to me to this day, and the community will miss her.
Lucy, thank you for all you've done for me personally and for the community. We owe you a deep debt of gratitude. Your caring attention has had a profound and positive impact and has shaped our field in a way that embraces science, technology, compassion, integrity, and the human experience.
We had a small technical issue there, but I wanted to thank everyone for joining us to pay tribute to three visualization pioneers, Alfred Inselberg, Bill Lorensen, and Lucy Nowell. I really look forward to raising a glass to Al, Bill, and Lucy in person in hopefully the near future. Thank you all, and we'll end the session now.
Pixel Clipper allows visitors to quickly and expressively extract visual clippings from visualizations and add comments to them. The clippings are useful for engaging the public with complex data sets because they are entry points into the visualization. This can be applied in a wide range of engagement experiences, such as the use of facilitated and ambient displays at public engagement events.
Progressive visual analytics provides intermediate results in the middle of computation to address a long computational delay. However, such intermediate results are uncertain, so findings from these results can turn out to be incorrect for the entire data. In progressive visual analytics with safeguards, we suggest to risk the uncertainty, but we allow humans to leave safeguards every time they risk the uncertainty.
Information about vulnerabilities helps defenders prioritize what they need to patch, but this information can be difficult to interpret. In this paper, we support interpretability using a focus-in-context approach to visualizing vulnerability data, including a clustering overview, plots that enable filtering based on severity, and explanations of text features and descriptions. We invite you to read our paper to learn more.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. Connect to the data you care about. Sort, highlight, drill down, or filter your data in seconds. Add calculations to extend your data. With Tableau, you can keep on asking questions in the data until you discover the root cause. Tableau, answer questions at the speed of thought. Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. Connect to the data you care about. Sort, highlight, drill down, or filter your data in seconds. Add calculations to extend your data. With Tableau, you can keep on asking questions in the data until you discover the root cause. Tableau, answer questions at the speed of thought.
Out-of-distribution samples refer to the test samples not well covered by the training data, like these black cats. They are misclassified with high confidence due to their black bodies. To explain why these samples are out of distribution, we developed OOD Analyzer, a visual analytics tool which provides an ensemble detection method and a grid-based visualization to detect and analyze out-of-distribution samples.
Suppose you want to see the overall commit structure of a new project repository. Using Git class tools, GitHub Network, or Git log command, it's quite burdensome to get overview and navigate data. We presented Githru as an interactive visual analytics system for the Git metadata to help users explore and understand the context of development history.
Several recent studies advocated the use of non-parametric density models for the improved characterization of data uncertainty. The non-parametric models, however, present the challenges such as increased memory and computational requirements. In this work, we propose an efficient non-parametric framework for volume rendering in the context of uncertain data and show their effectiveness in classifications via comparisons with the other statistical models.
Asteroids have always been and will always be a threat to life on Earth. Most likely, an asteroid will hit deep water, but what properties will actually lead to a threat like a tsunami? Ensemble simulations are a common tool to understand the effect of different parameters like the size of the asteroid. We propose an interactive visual approach to help analyzing deepwater asteroid impact simulation ensembles.
Digital humanities present great opportunities for testing new visualization approaches and evaluation techniques. However, and given the diffuse character and novelty of the field, it may also be intimidating for novel and senior researchers willing to get started in the discipline. In this paper, we propose a data-driven analysis of visualization for the digital humanities to identify key themes, authors, and relevant publications. So if you want to know more, please read our paper.
In this presentation, we introduce a provenance library, TRACK, which makes implementing provenance in web-based tools easy. TRACK introduces a novel storage model for web-based provenance tracking and has an associated history visualization, which can be fully customized. TRACK also contains multiple ways to save and share individual states or entire sessions of an application and ensures that exported data is easy to analyze in interesting and unique ways.
Billions of biologging records reflect animal behaviors on many temporal spatial scales, yet segmenting the time series on multiple scales is often avoided or impeded. Hence we present our multi-seg VA platform with its 3 contributions. First, multi-seg VA contributes tailored visual interactive features for multi-scale segmentation. Second, we show a new visual query language to flexibly configure scale-wise techniques and parameters. This VQL consumes a domain-oriented set of techniques, our third contribution.
White space surfaces are a novel approach to convey depth in vessel visualizations. The core idea is to shift all additional depth cues away from geometry and to use the usually empty space between the vascular structures. This allows us to display functional parameters on the surface and supporting cues on the background. We will explain how to generate such surfaces and how to use them as a canvas to further enhance depth and shape perception.
How many clusters can you see in these images? With different visual encodings in scatter plots, our perception of cluster count changes. We developed models that consider how visual density influences cluster perception. Further, we demonstrate using a threshold plot to optimize the saliency of clusters.
As commonly known, dimensionality reduction techniques and their interpretations are complex, biased, and uncertain. In drug design, this highly complicates the search for similar and new chemical compounds. To overcome this issue, Canva brings comparison of different molecular descriptors and properties into one tool, featuring planar, 3D, and table views for evaluating the trustworthiness of high-dimensional data projection.
The ever-evolving landscape of malware detection and invasion creates a constant catch-up contest between the defenders and the adversaries. We created a system which submits and analyzes a malware sample with Cuckoo Sandbox and then animates the battle between the malware and the anti-malware system. The Gotta Evade 'em All system is a useful tool that uses a familiar concept based on Pokemon, allowing the understanding of malware evasive behavior to be more accessible.
We propose X-matrix, a novel method for random forest interpretability. From a random forest model, a logic rule is extracted from each decision path on every decision tree. Once the complete set of logic rules is obtained, visual representations can be built for global and local explanations. X-matrix, making random forests interpretable.
Programmers often make mistakes like this. A BS function is incorrectly called with a string. A programming language can catch such mistakes early on, but for this, it needs a type system. We present Typical, an interactive visualization tool for programming language designers. Typical allows them to explore common function type signatures and helps create a type system.
A dynamic graph models changing relationships between entities over time. In this work, we present multi-scale snapshots, a visual analytics approach to provide an overview of a dynamic graph at multiple temporal scales. The approach consists of 3 steps: creating multi-scale temporal summaries, applying graph embeddings, and the semi-automatic visual analysis. The combination of these steps lets us visually explore how temporal and structural properties affect the overall dynamic graph.
Linking and brushing is very useful for interactive visual data exploration. Data-driven brushing tools are getting popular recently and achieve good results, for example the Mahanoda-based brush and the CNN-based brush. However, these brushing tools are optimized by the data from a large number of users, which are not suitable for everyone. In this paper, we introduce an adaptive brush model which takes the user in a loop to improve the brushing accuracy.
VIS is a visual support system for the development of visualization algorithms. It has live compilation, automatic version control, predefined interactions, and tools for visual parameter analysis. By displaying the complete history of the algorithm, users get insights into the correlation between source code changes and visual differences.
We propose an interactive ensemble analysis framework that provides flexible interactive exploration of the ensemble data. Time series characteristics of data can be obtained by fast browsing time steps. The region stability heat map view shows the stability of the selected region and provides region adjustment by directly clicking.
Program developers spend significant time on optimizing and tuning applications. But working with binary code to understand what compiler optimizations were applied can be challenging. We present our visual analytics system, CCNAV, designed to identify and assess compiler optimizations in binary code. Check out our paper to learn more.
In our paper, we address the problem of navigating complex multiscale and dense environments, such as these molecular models. We present a technique for browsing a model by clicking on textual labels, which we call hyperlabels. This allows the user to intuitively navigate the hierarchical organization of the model. For more details, read our paper or watch the talk.
SPOT-SDC is a visualization system that helps researchers understand the resiliency of HPC computation kernels to silent error corruptions. It gives users multiple perspectives of details with different granularity about the impact of SDC on an application's output. It also provides novel insight into how silent error propagates through a program's execution.
Predictions made by machine learning models can be hard to understand. Counterfactual explanations explain model predictions by telling the users how to obtain the desired prediction with minimal changes to the input. We introduced DIS, an interactive visualization system that supports counterfactual-based explorations on individual instances and data subgroups. Please check our paper for more details.
Interacting with large datasets could be painfully slow. We can reduce the latency with faster backends, but that's not always attainable. Here, we investigate a solution that only leverages techniques on the front end. We propose interaction snapshots, where users can view the results at a later time. We found that users experienced much less frustration and were able to complete the tasks faster.
Ecosystems are complex and dynamic. To investigate the dynamic nature of ecosystems, we have developed a prototype of a visual analytics system based on empirical dynamic modeling, EDM. EDM is a set of analytical methods rooted in nonlinear state space reconstruction. Integrating EDM with dimensionality reduction, brush-linked visualizations, and visual summarization support understandings of ecosystem dynamics.
Ray tracing techniques can create images of astonishing realism and beauty. In the last years, the performance of those techniques has been increased significantly using dedicated hardware. Who thought that it's also possible to accelerate this? We show how to dramatically accelerate force-directed graph drawing with RT cores, yielding a speed up of 4 to 13x. If you want to know more, please see our talk.
After determining the departure timestamp, the experts then moved to verify the recommended shuttle stops and routes. Note that ShuttleVis recommends the default shuttle stops and routes based on the metric of average distance. Then they observed that in our cluster 4, the system recommends Hejianjianyuan as the shuttle bus stop, but the experts identified that another drop-off spot Panshanhuayuan is located in the middle part in this regional cluster.
How do we represent remote users in synchronized visualizations while supporting divergent exploration? We present cursors, the basic unit of user representation in a collaborative visualization. They can vary significantly in appearance, as you can see. Cursors enable collaborative interaction techniques, such as peeking, tracking, and forking. To learn more, please read our paper representing real-time multi-user collaboration in visualization.
In this paper, we investigate design choices for work-couplet maps by domain experts. We tackle 2 research questions: how do domain tasks influence the design choices, and what equal error projection is preferred. Through a survey, we collected 40 couplet maps designed by 20 social scientists, and our analysis suggests that the choices vary across tasks, the projection was most important, and the equal error projection was preferred.
Magazine-style narrative visualizations can be challenging due to the need to go back and forth from the text to the visualization. We use eye tracking to monitor which sentence is currently being read and trigger visual links between that sentence and the corresponding data points in the visualization. Results show that the gaze-driven links increase comprehension of the documents without hindering reading time.
Hurricanes, air pollution, forest fires, urban sprawl, ocean plastics, politics, traffic jams, and pandemics. So many of our modern challenges are geospatial, and so much of our big data is geospatial. How is the VIS community addressing needs to visualize and analyze this data? Our review examines IEEE VIS's recent contributions to geovisualization and geospatial analysis.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. With Tableau, you can keep on asking questions in the data until you discover the root cause. Share your analysis securely. Your entire organization can access these interactive dashboards from any browser or mobile device to find their own answers. Tableau. Answer questions at the speed of thought.
In a visualization, laying out labels to data points needs to be done automatically with a fast labeling algorithm. We introduce occupancy bitmap. It's a data structure that helps the labeling algorithm to first quickly record the positions of existing marks and labels, and second, quickly detect overlapping of labels to the recorded positions.
We have seen many visualizations for tree data structures, but when showing changes in trees over time, some focus on displaying hierarchy, while others highlight their changes. With split streams, we combine two approaches and their individual benefits. We evaluated our method in a user study and consider it a general-purpose method for the visualization of dynamic hierarchies. Our JavaScript library is openly available.
DVR has always been from considerable interest to the scientific community. To this day, traditional desktop setups are the gold standard. However, what if we could utilize DVR in virtual reality? Now you think, VR and DVR are so computationally expensive, how is this even feasible? Come to my talk and we present you a straightforward solution to visualize volumetric datasets with high refresh rates on VR devices.
Data lakes can contain millions of tables. Data portals have tools like keyword search to find data sets, but often researchers don't care about semantics, but rather structural metadata. Can I find a dataset with many rows, few columns, and preferably a high number of unique values? Log Prospector visualizes structural properties based on the user's needs and helps researchers fish out datasets with appropriate structural properties.
In our current work, we visually compare two cohorts of segmented and classified tissue images, originated from single-cell omics data. To that end, we developed a data-driven and interactive workflow implemented in a multi-linked view system. Finally, we show the effectiveness of our workflow through specific case studies.
Morse complexes have shown a great utility in understanding the topology of complex scientific datasets. The noise in the scalar field, however, can significantly distort the Morse complex topology. Hence, we study the extraction of Morse complexes for ensembles of noisy scalar fields through their uncertainty visualization using our proposed statistical summary maps.